Welcome to chapter review and test for chapter 2, properties of elementary functions. Question number 1. This problem concerns these 5 function values. So we have the x values on this column, and we have the y values or the f of x values on this column. Your x at 2 is with f of x at 1.2. Our x with 4 and f of x 4.8. Our x at 6 and f of x 10.8. Our x at 8, f of x 19.2. Our x at 10, our f of x at 30.0. Letter A. On the same screen, plot the points and the graph of f of x is equal to 0.3x squared. So pretty much we are going to graph the function. And we will start this by, of course, creating a Cartesian coordinate system, defining our x and y axes. So these are our x and y axes. Let's define them. This is our x-axis. This is our y-axis. And our x is interval of 1. So 1, 2, 3, 4, 5, 6, 7, 8. So let's elongate this. Put it up to here so that we could accommodate up to 10. Okay, so 2, 4, 6, 8, 10. And for our y-axis, that's from 1.2 to 30. So let's accommodate from, okay, let us say 5, or let us say from 2. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 24, 26, 28, 30. So we now have our values. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And for our y values, it would be 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28. So let's do up to 28. So now we are going to plot the points according to the two rows. So our x is 2 and f of x is 1.2. And of course that will be located 2 and 1.2, so it's here. Okay, next we have 4 and 4.8. 4 and 4.8. So 4.8 lies somewhere in the middle of 4 and 6. So it's here. And then we have 6 and 10.8. So 6 and 10.8. So 10.8 is somewhere here. It's almost 11. Is it too high? Let's lower it down. It's here. Okay. And then we have 8 and 19.2. So 8 and 19.2. So it's here. And then the last one is 10 and 30. So it's pretty much above this axis. And So in that interval, okay, this is what I get. This is the function, the graph that I get. So connecting all of the points, I will get something like this. Okay? So let me highlight the curve. So it's like that. Okay. Over this domain from x2 to 10. Now at the same time I have to graph the function 0.3 x squared. And how do I graph that? We have to create a table. Well, let's say we have the same values. Okay, so we are going to fill in this table with the same values of x. And let's see what happens to the y. 2, 3, 4, 5, 6. So this is my x-axis, or these are the x values, and these are the y values, f of x. So my foundations are x2, 4, 6, 8, 10. And my f of x would be, so what are my f of x here? Noting that this is my function, okay? So to help us with the computation, let us use the computer or the calculator in this program. So 0.3 x squared, when my x is 2, I will have 0.3 times 4, which is equal to 1.2. If my x is 4, then I will have 16 times, so 0.3 times 16. And it gives me 4.8. When my x is 6, so that would be 0.3 times 36 equals 10.8. When my x is 8, so that's 0.3 times 64. And when my x is 10, that's 0.3 times 100. So notice that our function f of x is equal to 0.3 x squared is the same as this graph here. But with the exclusion that, of course, it's understandable because the domain given in here is from 2 to 10. But in my function, I would get my point for when x is equal to 0. So when x is equal to 0, my f of x is also 0. So meaning that this goes up to here for my 0.3 x squared function. So connecting the dots, so I'm connecting the dots. Okay. So you could see that they have similar graph, the given function and the table above the function. So this one is also this one. Okay? So for letter B, is the function increasing or decreasing? So this is my letter A. For letter B, is the function increasing or decreasing? Is the graph concave up or concave down? You could see that the graph is increasing. It's increasing without bound. Okay, so it's increasing exponentially. And also, it is concave up. So this is concave up. So the answer for letter B is increasing and concave up. Okay, Letter C, name the function in part A. This is a quadratic function. Okay? This is a quadratic function, but at the same time a power function. So this function is a power function. And at the same time, this is a quadratic function. Why quadratic? Because you can see that the exponent is 2. Okay? So with this given interval only, from 0 to 10, or from 2 to 10 in this case, from 2 to 10, okay, the function is increasing and concave up. But if we are going to graph the function 0.x square totally, it would give us a totally different graph. So the graph is like that. Okay? The graph is like that. So let us make it clearer. Our graph for letter A, which is f of x is equal to 0.3x squared, would have this complete graph with vertex lying here on the middle. Okay, this is our vertex. So for the given function with the tables 2, 4, 6, 8, 10 and 1.2, 4.8, 10.3, 19.2 and 30, it seems that it could be an exponential function. But when we take the whole graph together with this function 0.3x squared in letter A, now this is a quadratic function with vertex occurring at 0, 0, right? This is the minimum point of the quadratic function at 0, 0. And notice that in here, this function is concave down and is decreasing. But the given function values would have this graph. From here going there, it's concave up and increasing. Okay, so for letter C, the answer is a power function or a quadratic function. Whereas in the given, the function values given would define either a quadratic function because the domain is restricted from 2 to 10, whereas the letter A, which is 0.3x squared, is totally devoted to a quadratic function. Okay? So for letter C, name the function in part A. We already answered it as a power function, and at the same time it's a quadratic function, so it's a quadratic power function. And give an example in the real world that this function might model. So your answers could vary. Okay? There are a lot of models. For example, you have a ball, and that ball is released from a certain height. So it's released from a certain height. Let's say you are here. Okay? And you release a ball. Actually, you hit a ball here. And then this ball touched the ground. Okay? And then after touching the ground, it bounces off, going to the upper space. Okay? The upper space of this area. So this is one example wherein you can model the function f of x is equal to 0.3x squared. So your answers could vary. Okay? So the answer here is answers could vary. Okay. So these answers are questions for review problem 1.